Our today's topic is Introduction to Scilab, a free and open source numerical computing platform. Many of you might be familiar with the popular software MATLAB. This one is almost similar to that, but in the open source domain. I'll just introduce myself first before taking further. So I am Himanshu Bhatt, mechanical engineer and secretary at II South Gujarat Local Center. I'm interested in exploring and implementing open source tools at my startup Maxer Designs, and we are also helping others to take benefits through Maxel OSS. So with this, let us start and understand before going into Skylab what is open source. So when we talk about open source software, that is the software where its source code is available publicly so that anyone can study, modify, and redistribute it under specific licenses. Here, the biggest benefit is that you are not locked in with any of the software developer for any of the tools. And the examples of such open source tools are Linux operating system, Python programming language that mostly are aware today, Firefox browser, PostgreSQL, FreeCAD, etc. Some of these we have already covered in our previous webinars. So if we have to take an engineering analogy, you can consider that if you get a sealed machine, even if it is free, you cannot open it, you cannot change its functionality, you cannot repair it. So that is called a closed source kind of thing. Whereas if we correlate it to open source, the machine which comes fully with its drawings and the maintenance catalog so that you can repair, you can update the machine, you can change its functionality to your requirements. That becomes the open source tools. So now you can understand that open source tools may be free, may not be free, but 99% of the cases, open source tools are always free. So that is why it is called FOSS, free and open source software. There are various licensing terms even for the open source software, and some of them are very permissive and different types of copyleft and all. But as a user, the biggest advantage is we don't need to worry about this. It is only applicable when we are developing something on top of those available features. As a user, we just need to see that, okay, the software is available in open source. Go to its GitHub repository, just copy the repo and start using it. So, are the open source software reliable? If you have to answer this question, we understand with some statistics that today 96% of the internet servers are operating on Linux system, which is open source. All our mobile devices, Android is based on Linux. So Linux has already proven open source community has already proven its reliability. Now it's only coming to struggles as application to particularly engineering field. So this struggles is because of few things which I have listed down, that limited awareness. Many of us are not aware that some open source tools are available which are comparable or even more feature rich than the counterpart of commercial softwares. So that is the lack of awareness and visibility of the open source softwares. Second part is the learning curve, because these softwares, when it is commercial software, they also give trainings, they also give some academic licenses free to institutions. So this way, people are already aware and some learning is already there. The catalogs are available, training materials are available. Whereas in open source category, you have to explore by yourself, reading through the help files. And support is also not centralized, and we are relying on community forums for open source tools. So these are some of the points where we feel that open source software implementation is getting a step back, and this is our effort to overcome these struggles and spread awareness about various open source tools. That is how we are conducting this webinar series through Institute of Engineers India. And today with us, we have expert speakers from FOSSE, FOSSE team of IIT Bombay, Miss Vinita Parmar. She is a senior project manager at FOSI project and working on Skylab. And with her, Miss Rashmi Patankar. She is also a project manager on this Skylab project at IIT Bombay. So with this, I hand over the webinar to Ms. Vinita Parmar. Over to you. Thank you.
Hi, good afternoon, everyone. So, a very warm welcome to all the students, teachers, researchers, and whoever is present here. And thank you for the introduction, Mr. Himanshu. Uh, and thank you for organizing this through FOSSI. So, Scilab basically is an open source tool which is equivalent of MATLAB, as Sir has already mentioned. So, it is used in various fields. So, Rashmi will give you a demo as well as will give you the insights of what we have for Scilab, and then I shall interact with you that what all resources are available and how you can contribute to this wonderful tool which we have. Okay, Rashmi, you can go ahead.
Yeah, sure. Thank you. Let me share my screen. I hope my screen is visible.
Yes, Rashmi.
Okay. Okay, so hi, good afternoon, everyone. So now in this session, we'll talk about Scilab. So what is Scilab? So Himanshu sir has covered this topic that why open source tools matter. So I'll not go into those details once again. So I'll skip the slide. We'll directly get to what is Scilab. Scilab is a free and open source software mainly used for numerical computation simulation. So many people compare it with MATLAB because the syntax and workflow are quite similar. In fact, a large amount of MATLAB code can be adopted easily in Scilab. If you know MATLAB, then you can easily adopt how to use Scilab because it has got around 95% compatibility with MATLAB. So it is basically designed for engineers, scientists, and you can use it for mathematical applications. It supports modeling. You can do simulation. I'll show you a demo like how you can simulate a complex system, complex dynamic system that I'll tell you further in the session. You can visualize the graphs, the outputs of very large systems. You can optimize the performance of a system. All those things can be done using Scilab. Uh, Very beautifully, it is available on every OS. You can use Windows, Linux, or Mac OS. Any OS is fine. There are no restrictions. Where Scilab can be used, there are multiple domains where Scilab can be used, but how you can use it, so as you know that in Python we have some libraries like NumPy, SciPy, Pandas. So likewise in Scilab we have toolboxes. We call them as toolboxes. So using these toolboxes you can use Scilab in various domains. So along with Scilab, there is one more beautiful tool that is XCOS. As I was saying that you can use Scilab for simulation, for simulating the dynamic systems. So how you can use it? So there is this tool available which is called as XCOS. It is a great alternative to Simulink. So those who have used MATLAB, they might be aware with Simulink. So XCOS is exactly similar to Simulink. It is nothing but the collection of the blocks. There are multiple blocks available. You just have to drag and drop those blocks, connect them together, and create a replicate a complex model in XCOS using this tool. So it is nothing but the graphic modeling and simulation tool basically. Moving further, so why industry should consider using Scilab? Not only industry, even students, everybody, why should they consider using Scilab? Obviously it doesn't have any license cost. Most importantly, it is open source, so anybody can download your code. if any industry is using it for one particular product. So if some student is studying that product while in the last year of engineering, they can simply download their code since it is open source. They can modify, tweak it as per the requirement, and then use it. So these are the benefits of having it open source. Then it is, as I was saying, it is suitable for rapid prototyping and simulation. Uh, then it is useful for algorithm development and testing. Earlier, as I said, that it has got MATLAB-like syntax. So, uh, if you know MATLAB, then you can use it easily adopt using Scilab. Supports automation and engineering workflows. Um, Even students, PhD students, masters, students who are pursuing masters, everybody can use Scilab for pursuing their uh, degree. While pursuing their degree, they can do their final year projects. Many things can be done. It can be integrated into training and educational programs also. Next is these are the key features of Scilab, but these are not the only features. I could not fit in all the features of Scilab in one slide. So I have just listed down a very few. So these are some basic features of Scilab. You can perform numerical mathematics, as you know that this is the numerical computation software. So basic mathematical problems you can solve using Scilab. And these things can be done just with one line command. That is the beauty of using Scilab. Like, just to find out the determinant, we perform so many steps. To find out eigenvector, we perform so many steps. But then by using Scilab, there is just one command that helps you to find out the output. Then you can do integration, differentiation. These basic things you can do. You can solve ODEs. Then you can use it for plotting various types of graphs. I'll show you what type of graphs also you can plot. Then, as I was saying, that it comes along with a tool called as XCOS, which you can use for simulate the dynamic systems. And one more very beautiful feature is it has a graphical user interface. That means you can create an app using Scilab. It's like, you can create a dashboard for a complex system that is running behind. So you can create a good dashboard where you can add some push buttons, radio buttons. You can have check boxes. You can have slider. You can have graph access for plotting graphs. So all those things can be done with the help of this graphical user interface. Next, as I was saying, that Scilab can be used everywhere in every domain. Again, these are not the only domains where Scilab can be used. Can be used everywhere in every other field, but then uh, these are some fields that I've mentioned over here. So core engineering, you can use it for control system, signal processing, optimization, linear algebra. The emerging technologies these days are artificial neural network, computer vision, machine learning, deep learning. There also you can use Scilab. Even for performing the flight dynamic systems, also there is the Celeste Lab toolbox is available, which you can use. Then for parallel computing, digital logic design, and many more things are there, where many more domains are there where you can use Scilab. So as I was saying earlier, that we have one powerful tool called as XCOS that comes along with Scilab. Uh, just before this, I was talking to Mr. Himanshu. He was asking me like, these days Octave is also there. Why are we not using Octave, and why only Scilab? Why are we only using Scilab? Why are we not promoting Octave? Because Octave does not have this tool called as XCOS. It does not have any similar tool to XCOS. So that is the main difference, because otherwise Scilab and Octave go hand in hand, but then this XCOS tool is not available for Octave. So that is why we chose Scilab. So XCOS, as I said, that where XCOS is a graphical simulation environment available inside Scilab. So you do not have to download it separately. Once you download Scilab, you easily get access to this tool called as XCOS. So instead of writing only Scilab code, users can create systems using block diagrams, using blocks and connections. So there will I'll just show you how the interface looks like, so then you will get an idea. So it is very useful for dynamic system modeling, control system simulation, continuous and discrete system analysis. Engineers who are familiar with Simulink can easily understand XCOS very quickly because the workflow is similar only. So I'd like to show you some industrial applications of Scilab. So then you will get that confidence where Scilab can be used. I hope this tab is also visible to you. Can anyone just confirm whether it is visible?
Yes, Rashmi.
Okay, thank you.
Yes, yes,
So
visible.
these are some use cases of
Also,
Scilab where
Rashmi,
Scilab can be used.
just
Yes,
you can say that XCOS is equivalent. I think the people are more mainly is familiar with MATLAB. So just interrupting Rashmi in between that, MATLAB has a simulation called Simulink. So Simulink is used for in MATLAB. So XCOS is something similar to Simulink. So before Rashmi moves forward to the demo, I wanted to clear this. So that's why I just now continue, Rashmi.
thank you, Vinita ma'am. So yes, so XCOS is similar to Simulink in MATLAB, as Vinita ma'am was saying. Moving further, so these are the use cases of Scilab in industries where you can use Scilab in aerospace department, in automotive, in energy and meteorology, metallurgy, in pharmaceutical industry you can use. For research and education you can use. These are some examples where Scilab can be used. So many people are like, are not aware of the uses of Scilab. So these are the applications. Let me just read it out for you. Some applications are the model of metallurgical reactor. You can use it for metallurgical reactor. Then flight data analysis of Arion launchers. Can you see flight data analysis can also be done using Scilab. Then you can optimize the aircraft design. Then cardiovascular wave analysis model, that means for biomedical engineering also Scilab can be used. For aeroacoustic test, also, everywhere you can use Scilab. The sampling valve control of a diesel engine, LNG operation. I would want you to, go to this page, go to scilab.org, then use hyphen cases. You can go to this link and see where Scilab can be used. And if there is any final year student, they can also go through this website and see the use cases, and you can take up any topic as your final year project, and then you know uh, polish it further, and you can create something really good with the help of these applications. Coming back to the presentation, so now we'll see how to install Scilab. So again, we'll go to this scilab.org website. Here you can see this download Scilab. This will automatically download the latest version of Scilab. If you go to this link, it will show you the previous versions also of Scilab available. Scilab 2026 is the latest version. Scilab 2025, 2024. As you can see, I was saying that it supports cross-platform. So these many platforms, it allows you to use Scilab. If you want to see the previous versions of Scilab, they are also available. You can explore this further. So by clicking on any of these links, you can download the required file and then install Scilab on your system. So I'd like to now show you one small demo of Scilab and XCOS, how the entire interface looks like. So then you'll get an idea. I've already opened Scilab on my system. I'm currently using Scilab 2025.0.0 version. You can use the latest version as well. So uh, I'll just start with a very basic example, and then I'll show you some advanced level examples as well. So I'll just take one, the matrices example. I am now defining a matrix of 2 cross 2 matrix. Here I've defined the 2 cross 2 matrix A, And let me define another matrix. You have defined another matrix. So you can just, add these matrices, subtract one from the another, or else you can multiply them. You can find out the determinant. As I was saying, that there is just one line command that can be used for the basic mathematical operations. You can find out the determinant of A, or you can find out the eigenvalues as well. There is this command called the spec, using which you can easily find out the eigenvalues. So this is one very simple example. I have actually created some, uh, examples for you just to show you that how Scilab can be used for advanced topics as well. So this is the first example. Yes. So this is the example to find out the unit step response of a second order transfer function. So what is a transfer function? Most of you might be knowing this. A transfer function in Scilab helps engineers mathematically model and analyze how a system responds to inputs, making control system design and simulations easier. So this is the second order system, which is 300 divided by s square plus 20s plus 600. So here I have defined s is equal to percent %s. That means I have defined the continuous time variable. The syslin command will find out will actually do the main part. It will find out, it will define the this entire system, this entire equation as the continuous time domain system. Then here I have defined the time interval. The csim command will actually, plot the step response. It will simulate and plot the step response of this transfer function. I'll just execute this code. As you can see, this is the step response of that second order system. Let me just zoom in. Okay. So here you can see that this was the step function, and then after we gave this transfer function, it gave us this response. This yes. So this is how you can actually calculate a transfer function of a system. Then another example. Uh, there is one example called as pole zero plot, as in when you want to check whether the system is stable or not, you find out the poles and zeros of that particular system where they are lying, and then you can find out whether the system is stable or unstable. So this is one basic example of that. Here again, syslin command I've used to define the continuous time domain. C is to say that it is the continuous time domain system. Then I'm just finding out the roots, and this P margin, G margin will find out the phase margin and gain margin. I'll just quickly run this example. I'll not go into the details. I just want to show you that how you can use Scilab for, for the advanced level examples.
Excuse me, Rashmi, I think your window is quite, the font is not that big. Mr. Himanshu and the admins, can you just tell us whether the screen of Rashmi is quite visible? The commands are visible, what she is pointing out?
Yes, screen is visible, and but yes, you are right. Reading commands is difficult. We can just see that something is happening, and then it is getting
Yeah,
updated.
just I think Rashmi, you can increase the font of your window.
All
Okay,
right,
because there's no point if the commands and everything is
correct.
not visible.
Yeah, yeah. Thank you so much for telling me that.
Okay, this is great. Actually, we were not aware that there is a feature to update the fonts, so we thought it would be like this only.
No, no, you can easily do that. Just
Rashmi is our technical Scilab expert, so she knows many things.
So this is one of the demo to of the feature.
mm,
So, Rashmi, it will be
just
good whenever
once.
you are talking about some
Yeah,
command. It is better
yeah,
now.
yeah, yeah.
You can just highlight it so that the audience
Sure.
knows. Yeah,
Yeah, yeah, yeah, sure, sure.
yeah.
I'll do that.
Continue. Sorry to disturb again, but this was necessary
No, no,
because
no.
it is
This was
not
necessary. Yeah,
visible.
yeah, yeah. I totally
And
understand.
it's good, ma'am.
Yeah,
These webinars are being recorded on YouTube also. So even in future also, if you want to tell
Yes.
someone to refer, it would be much useful.
I should have done this earlier. Definitely.
No, but we
Totally
don't
could
know now
work.
how it is visible.
Yeah.
Only during the demo you will know. So, something from the audience. Are there students also present, or they're only faculty members, researchers? Till Rashmi sets up her
It
screen
is
and
too
everything.
big now.
No,
I
but this is
think it
good.
is too big.
This is
This
good.
is good. I'll just separate this out so then it will be much
Yeah,
better
this looks
to
much
see.
better now. Yes.
So, do we have students also in the audience?
Uh, yeah, sensor, Kinshuk sensor. Hello.
Yes, sir.
Yeah. So, is it better now? The screen is better now. Rashmi, you can highlight one command and show.
Definitely, definitely. So I'll just go a little slow now again.
Yeah. You can
Okay.
repeat
So
the graph thing. Okay.
yes, the
Is
earlier
it better
example
now,
also I'll
sir?
explain
Because
once again.
I
Sure.
thought the font was really
Yes,
small.
the
So,
Kannada fonts are now better.
okay. Thank you, sir.
Okay.
If
Great.
anything is there like this, please let us know.
Yes.
Yes.
Yeah. Thank you.
Thank you. So once again, I'll just show you the first example. I'll not go into
Yeah, sorry.
the like
Kinshuk
technical
sensor.
details,
There
but
was
then
a
I would like to
query.
just show you. Pardon?
Yeah, to sensor, Kinshuk sensor. There was a query like, what are the profile of participants for today's session? Like
Yes. Yes.
majority
Yes.
who are there.
Yes.
Kindly share the profile of the participants' profile. Participants are very less till
So
now.
yeah, I just checked today. We have
Ah,
very I think
So,
4 or 5 participants are there
yes, yes, yeah,
apart from
Can they
me.
just unmute themselves just for like, few seconds and tell their background and things?
Yeah, yeah.
Do we have any student? That's what my question was.
So from
participants
participants, any students, any college students,
are difficult to identify who are the. Hopefully,
you
all are.
can raise your hand.
The video is not visible actually. So, no, it's okay. We just wanted to know the background so we can do the demo and the
Yeah.
explanation towards their interest. That's the only
Yeah. Yeah. So
requirement.
otherwise, if
Mm,
they are just,
Otherwise, it is post lunch. So
engineering students, then it will be like too heavy for them.
yeah,
Now, ma'am, we can, because this is an introductory webinar and we are briefing about the capabilities and features of the software. So let it run through the way it is, and then those
Sure.
who are
sure,
interested in learning bit more, they can go to GitHub and learn more.
sure, sure. So Rashmi,
For sure.
continue. Yeah.
Yes.
Thank you.
Okay.
Thank you
Thank
so
you.
much.
Thank you once again. So I'll just, go back to the previous example. The previous example I was talking about finding out the unit step response of a second order transfer function. So for that, it is a very simple example. The system is basically 300 divided by s square plus 20s plus 600. This is the transfer function. And we want to find out the step response of the second order system. Okay, so for that, the main command here, we first of all we should define this entire transfer function as the continuous time domain function. That is why we have added here C. The syslin command will do the needful, and then the csim command will plot. That's it. It will simulate the step response. Uh, and if I simulate this, let me execute, and here we see the output. So this is the unit step input response of this particular transfer function. So those who know this background, how to find out the step response of a transfer function, they might be able to relate to it. So moving further, this is another demo of finding out the pole zero plot. This usually we used to check whether the system is stable or unstable. So this is another example. So again, here this is very simple example. Again, here I've used a syslin command, and I'm just finding out the roots and zeros over here. Oh, sorry. Yeah, roots and zeros, and then poles I'm finding out over here, and then just we are finding out the body plot of this entire system, and then after finding out the body plot, we'll just find out the phase margin and gain margin. So let me just execute this. I really don't want to go into the technical details because otherwise it will take too much of time. I just want to show you how Scilab can be used and where Scilab can be used, because many people are still not aware of the usage of Scilab. So I'll just define some random numerator for this. Let us say S. That's it. This is the numerator I defined. Define the denominator for the system. So what basically I did is I just made the program a little interactive, just so that, I don't want to, the first, this demo was, very strict to this particular transfer function only, where I want user to input some values, and then I see the output. That is why I just made it interactive a bit. This is the denominator. Here I get the answer, and zeros and poles are these, and yeah, this is the output that I get. So moving on further. So this was the demo of Scilab. Now I'd like to show you a demo of Xcos. So how to open Xcos? I just type the command Xcos. The Xcos interface gets opened. These are various palettes. Palettes as in these are some groups where some blocks are grouped together. You just have to find them out. Sources means the input block. These are some blocks available under the sources palette. These are the input blocks. You can see that, it has got only the output arrow key, right? There is this arrow pointing towards the right. That means this is the input block. There is this sinusoidal wave. This is square wave. Then we have ramp response. This is sawtooth generator. This is again pulse generator, step function. These inputs like these are available. This is the sync block where you can see the output. Sources is nothing but the input. Sinks is nothing but the output block. So these are the output blocks available. We generally use this C-scope block to view only one single output. CM scope is to see the output of the multiple scopes. That's it. Then there are various different types of output blocks are available, which you can explore later on. Yeah, in this, you can also import the CSV file And you can then analyze the data that is there in the CSV file using Express. That also can be done. That means the data analysis part also can be done using Scilab. So I'll just take up one very basic example. I'll take the step function. See, this is how you do it. You drag the block from here and drop it over here on this, empty drawing tool. This is Untitled Expose window. This is the drawing tool where you have to just drop the blocks. I'll take the sync block and just show you how the step response or step view looks like. So this is the input block. This is the output block. Can you see this red arrow over here? This is like, event driven block. So I need one event generator. I'll take this clock. Now just simply connect this over here. Connect these two. That's it. This is like very basic example. Now I'll just simulate this. Can you see this small step over here? Just zoom in at this small step. Can you see over here? The step, this was unit step response. That is why the value just stopped at 1. So this is how, you can make use of XCOS and you can simulate the complex dynamic systems. Then there are multiple other palettes are also available. This discrete time systems palette is also available. This is again the to find out the transfer function, but in the discrete time system. In continuous time system also, this can see 1 upon 1 plus s. This is to find out the transfer function. This is the transfer function block in continuous time systems. Then this mathematical operations palette is also there. Gain block is there. Log block is there. So many various blocks are available. Summation block is there. Then electrical blocks are also available. This capacitor, diode, current sensor, inductor, NMOS, op-amp, PMOS, PNP, whatnot. So many things are there in XCOS. Then this is the flip-flop, SR flip-flop block is available. And if you double click on it, you can, this is the D flip-flop. Once you double click on any of these blocks, you can set the parameters also of that block. The step time. Earlier, I said this is the unit step response. So if I keep it 5, then this will be now the value will be 5. If I just simulate this, can you see this? Sorry, what did I do? Yeah, this is the step time. So it will take the timer of 5 seconds and then it will start the step response. So that is why it started the wave at 5. Yeah, over here. So likewise, there are so many palettes available. I would want you to explore this on your own because I have very short time to explain everything. I'd like to show you a few examples as well. Uh, this is the example of pitch simulation of an aircraft. This is the PRD controller. This is the transfer function block. This is the PRD controller. Once you click on this PRD controller, you can set all the proportional, integral, derivative parameter, and then you can just set this PID controller and give it to the transfer function. This is the transfer function. This is the actual example taken from a research paper by one of our students. She did this example by referring to that research paper. In that, this transfer function was given already. So she just used this transfer function and she find out the answer to this particular to her problem. This is the pitch simulation of an aircraft. Once I simulate this, yeah, this is the PID response of that particular transfer function. Quickly close this. And get back to my presentation. So these are some examples of XCOS again. This is some, again, high-level example. Car suspension system is there. Again, one of our students has done this. Then this marine diesel engine speed control system using PID control. Again, one of our students has done this. So, such type of, I hope you can see this. So such type of, dynamic systems you can simulate using XCOS. So I hope now you understood how Scilab and XCOS can be used together. So Scilab can plot different types of graphs, not only the 2D plots, it can plot logarithmic plots, polar plots, 3D plots, this mesh plot, scatter plot is there, bar chart also you can plot. Many different types of plots are there. I could not again fit everything in this particular presentation. You can explore this on your own, or in case if you have any queries, you can get back to us as well. Then earlier, as I was saying, that it comes along with a beautiful tool called as graphical user interface, using which you can create an app using Scilab, right? So here, as I was saying, you can create a dashboard in short. You can have a complex system running in the background, but then to the user you want to just simplify that particular system, so you just create a simple dashboard. Okay, it is like a mobile app, but then in the background many other programs are happening, right? So you can have this push button, radio button, checkboxes, slider. You can add all those things and create a beautiful UI for your complex system. So these are just examples. This is a very simple example of plotting a sphere. This is a slider. Once I move the sphere left and right, it will decrease and increase the value of the radius, and it will show you the output. This is a screenshot. That is why I cannot change the value. This is again another example. This is the dashboard of one of the complex systems, which is 1D finite element analysis of suspended column. Here, what we have done is we have added some input boxes to input some values. This fixed end diameter, free end diameter, whatever it is. So we just enter the values over here, the input values. Once we click on this is the push button, provide the solution. Once we click on that push button, we get the output over here. These are the output boxes where we get the output. Then this is the example of audio analysis and manipulation. These are all the push buttons. I can get sound file, play audio, analyzing time domain. So once I click on these push buttons, some other program runs behind, and then that particular process gets carried out. These are like, to change the speed of that particular audio file, 0.5x1, x 1.52. So you can change likewise, you can add multiple such elements on your GUI dashboard and create a very interactive uh, app for your complex system. So this is very useful when you do your final year project or even a mini project where this can be used. This is another example of single and multi-antenna wireless communication system. Again, here, as you can see, this radio button is there, relay and AWJ, and these are called as the radio buttons. Again, once you click on this will open up the list. This is called as the list box. One, if you click on one, then 1, 2, 3, 4, 5, all those options will be available. So these are the push buttons. So all these things can be done using Scilab. And that's it with the features of Scilab. And I really would like to thank you all for listening to me patiently. If you have any questions, you can ask me. Or if you have any further questions, if you have any questions later also, you can get back to us at this particular email ID, that is contact@scilab.in. We are always available for you. And I end my presentation. Over to you, sir. Himanshu, sir, are you there?
Yes, I'm
Uh,
here.
yeah.
Yes, thank you, Rashmi. And this was very nice presentation and detail. Yes, obviously the time was less, and we just wanted to cover briefly about the basics introduction of the software, which you have done very nicely, explaining
Thank you, sir.
various scope of the software. And yes, highlight of the tool is the Xcos, which I was not aware about it. So I just scrolling about how we can use it. So it's very useful. Sure, we will get back to you on further details once we start implementing it for some practical applications. And
Yes, sir.
with this, I take a moment to thank this Institute of Engineers India platform for
Sir,
providing this
actually,
opportunity to share the data.
Himanshu sir, the reason I was asking if there are students, because we have many activities in Scilab, resources available in Scilab, where these people can contribute, and if there are 5 minutes, I can just show that if the students are interested to know about it. Otherwise, we can
Yes, we,
conclude here.
yes, definitely. Because as we mentioned, this is also being recorded on YouTube. So even
Yes.
in future also, if someone comes across, they can always refer to the details.
Yeah. So, like Rashmi has told all the technical details about Scilab. Hope you all have understood. And we have a platform. I'm just sharing my screen. Um, just let me know when it's visible. Yeah. So we have something called scilab.in. So you can go to scilab.in and we have different projects here. If you see on the left hand side, we have the case study project, we have the XCOS textbook companion project, we have the Scilab textbook companion project, lab migration project, FOSSEE toolboxes. So these are some projects where the students can actually contribute, and then you can get a certificate which is really useful for your placements. So certificates, if you see, completed case studies, these are the students who have actually completed the case study. So see, Arpita from IGNU completed her case study in 2026 itself. This is her case study. Where if you click on this, you can actually see, download the codes. So this can be used as a resource, as well as you can yourself contribute. You can send a proposal to us, complete the case study, and your name can also come here. So this is a very good platform where you can earn certificate, as well as you can get recognition on a government recognized project website. So all these students, it really helps in the placements and higher studies. If you go abroad, they really want to know what you have done during your bachelor's. So these kinds of contribution which really will help you in future. So we have actually a textbook companion project where we can help you convert whole of your MATLAB lab to Scilab lab, or Octave also is a good alternative. But we basically look forward for Scilab because it is a complete package in whole. Okay, so you can actually contribute to send us a proposal. If you are a faculty member, you can send us a proposal, tell us which lab you want to convert to, and we can help you convert that proprietary lab to a open source lab for in this Scilab. Okay, so we have digital signal processing. We have, so these already are there. If your college is using any of this labs, you can refer the codes here. Here also your institute will get recognition. This actually helps in NIRF and NAC accreditations to the institute, because even the government is now telling us to use open source software slowly and become like Viksit Bharat. And they
Yes.
also want us to be independent of and free from these proprietary software. So the actual term of digital India comes from using the open source software tools which are available. So similarly, we have XCOS textbook companion, Scilab textbook companion. So all these you can actually contribute to, or you can use it as your resources, and get certificate, get recognition, etc. Also, FOSSEE has amazing toolboxes which we have published. FOSSEE optimization toolbox is published on the actual main Scilab website. If you see atoms.scilab.org, this is the Scilab developers website. So FOSSEE has released this toolbox, and you can see there are so many downloads already 69,210 downloads. So apparently MATLAB also has a optimization toolbox. So we are actually trying to create these toolbox so that Scilab becomes equivalent to MATLAB, and people can use it without even in their masters or in their research area. For bachelors, definitely it is good, but even if you are into research and all, you can definitely slowly switch to Scilab, because we are trying to develop more toolboxes. So optimization is one of them. Then recently we did a signal processing toolbox. Already 1761 downloads are there for this one. And earlier we had done Scilab Octave toolbox. Because we are talking about Octave, I thought I'll let you know this also. So if you're not comfortable with Scilab, you can actually convert your whole thing into Octave and start using that also. Okay, so that is also there. And there's one amazing thing which Fossey has developed is Scilab on cloud. So since Himanshu sir told that how it is useful in mechanical engineering, so here I selected mechanical engineering for you. Then engineering mechanics is there. Then you see
Okay.
uh, engineering mechanics example I have taken. And there's this chapter called kinetic of particle, and kin of a part. Sorry, I'm not a mechanical engineer, I'm an electronics engineer. So if I would have pronounced anything wrong. So here is the code. If you select all this, you get a code. So these are
Okay.
the codes which are already present on scilab.in textbook companion project I was talking about. So people already have contributed to these kind of thing, and we have a repository of all these codes already available. So this is from a solved example. This is a solved example. It's a 12.41 example of this particular book, of this particular chapter,
Mm.
and this is the solved example, which is then coded into Scilab. Students have submitted that, and this is the Scilab code for it. You can see that here the Scilab code is. Now, if I click on execute, it will show you the output on the left hand side. So this is the output which we get, right? So this is
Mm.
something which MATLAB doesn't have. This is what the Fossey people have developed. uh, Students like you only have contributed, and we do internships also. And people like you have contributed, and we have built a community. So it's really an amazing tool. So for students especially, you are building your career now. So if you add these things in your resume, it will really be a good opportunity for you in future. Okay, so this is what I just wanted to show you, that there are many resources available. People say that documentation is not available for open source software, there are no resources available, how can we use? But there is no excuse now. We already have everything available for you. You can start using it, and if you have any doubts, do let us know. We are available at contact at scilab.in. Rashmi has already told you, or info at fossey.in. We will then forward it to the concerned person. I hope you all like the demonstration and the resources which we have told you about. And thank you very much for taking time out on a weekend and joining. Thank you so much. Thank you, Rashmi. It was a very good demo. Yeah, over to you, sir, Himanshu, sir. Thank you so much for giving Fossey this opportunity.
Great, ma'am. It's always great to have such discussion and knowledge sharing. It was really worth mentioning that you have so many solved examples already available, so people can just review that and change some parameters and get updated versions very easily. So with this, yes, it will not be only beneficial to academics, but I hope it benefits to industries also with the open source tools and available codes in your this online version. People should be able to utilize that, and I'm sure they'll be able to get much more help from the software now onwards. So thank you all for joining, and have a nice weekend. Goodbye.
Thank you. Bye.
Thank you, sir. Bye.
Thank you, madam.
Okay, bye. Good evening. Bye.